Hi everyone, today I'm going to show you how to do custom MIDI controller mapping using SYSEX. Now hopefully you'll be able to understand it a bit more, and I'm going to show you how to do your own custom mappings. So we're going to use the JD-XI as a synth, and specifically we're going to look at the analog part. The analog part is missing a lot of settings, and they're usually mapped to the MIDI CC or control change messages. However, the JD-XI has an extensive SYSEX implementation, so I'm going to show you how to get the SYSEX working as a MIDI controller. The JD-XI is missing some ADSR envelope performance controls for both the amp and the filter, and I'm going to show you how to set up a controller to use these. Also, the JD-XI can respond to Aftertouch messages, but it doesn't have Aftertouch on the actual keyboard, so we'll explore how to use this feature. Now for this demo, as you can see, I'm going to be using the Roland A-500 Pro MIDI controller. This has Aftertouch and SYSEX. And as always, you'll find the links in the description for downloads and for the software I'm using. All right, let's have a look over at the Mac. We're going to use the A500 Pro editor. It's the software that comes with the A500 Pro MIDI controller, and we're just going to set up just a blank template. So nothing here is actually assigned to anything. All right, next we are going to need to look at the JD-XI implementation PDF. Just a look at this, it looks a little daunting, but it really isn't that hard to read, and hopefully by the end of this video you'll feel comfortable reading this one. We're also going to be using this MIDI monitor, which is a window that's part of the MIDI Quest Essentials application, and even in the demo version, which you can get for free, you can still use this. So lots of downloads in the description. We're also going to use the calculator, which is just a standard Mac calculator. Now on Windows, the calculator that comes with it also has this feature. So we're going to hit Command and hit the number 3, and it brings up programmer mode. And the reason why we need programmer mode will become evident in just a sec. So now, before we go into how to set up the controller, I think it's probably a good time to give a brief SYSEX lesson. So what is SYSEX? System exclusive is a MIDI standard form of message communication which allows custom and flexible communication to devices that manufacturers can uniquely program. And this can be anything from controlling parameters to updating the firmware. So it's a pretty flexible little thing. Now, SYSEX uses a hexadecimal or a base 16 counting system. And we use, in standard counting, we use a decimal or base 10 counting system in our normal everyday maths. So let's have a quick look at this notepad I've got over here. And what I want to do is I want to show you just how the hexadecimal counting system works here. So you can see the numbers 0 up to 9. And then it goes A, B, C, D, E, F. Now, if you count all of those numbers and letters there, and there's 16 of them, that's why it's a base 16 system. So we know decimal is the 10 base system, hexadecimal is a 16, but just for a bit of fun, do you know of another number counting base that we commonly use in computing? If you do, leave a comment below and tell us if you know what it's called. Okay, so how this works is the numbers all have numerical values. So when we get to the letter A, that becomes the 11th, 12th, 13th, 14th, 15th, 16th value, okay? Hex values are shown using this notation here with what we call a byte pair, or 00, and then a H. The H just means that we're showing a hex number. Some other places you'll see hexadecimal written with 0x, and then the 2 pair, the byte next to it. And that all just means that's a hexadecimal number as well. So don't get confused by this. Let's just have a quick look at the Roland manual. And you can see here is 8NH. The letter H just means that is a hexadecimal value. Notice that in the manual that everything in here with hexadecimal values are pairs. Let me just keep scrolling down. Over here on the left, you'll see these values. There's 2 numbers and a letter H, a number and a letter H. Remember the hexadecimal does use the letter F. Okay, so these pairs are known as bytes. And we're going to go back to my little note page here. What we want to do is we want to have a look at how this counts. Up the top, you'll see a little graphic above my little notes here, where up there somewhere, where you can see I've done 3 rows of hexadecimal counting. There's 16 per row. So you can see the bytes are in pairs. What I want to do is I want to quickly show how we are going to calculate hexadecimal. And what we're going to use is a little formula. The first two numbers we'll call the first number A, the second number B. Right? So let's write that down on here. Okay, A and B, and we're going to use this formula where we're going to times A by 16 and we're going to add B. So there's our little formula there. Now let's have a look at these numbers up here. So let's look right over here where we've got right on the far right hand side in the middle column, middle row, 1F. So when we write 1F like this, we can either write it as 1FH or 0x1F. And you might remember, I just went through that a second ago. So what we do is we times the first number by 16. In this case, it's 1. So 1 times 16, 1 times 16, all right? This is the A number, which is equal to 16. And then we add the B number to it. In this case, the B number is F. And as you can see, F is 15. Okay, so 16 plus 15 is 31. So our decimal value of 1F should be 31. All right, let's go over to our calculator and let's grab our 16 base number system. So you click on the 16 here and we're going to go 1F. Notice how it's 0x here. That means it's a hex number. If we hit the 10, it will calculate 31. So we got that right. So that's just a quick way of how you guys are going to calculate your SYSEX. And we can go backwards too. So we can say, right, how do we go from 31 decimal and how do we get the hex value? And you can just do that. 127, which I think is 7F. Bang. Okay. So you don't really need to know this part so much, but it's handy. What I want to do just quickly too is show you a little cheat. In that MIDI implementation manual, you'll see they've already given us a hexadecimal table. So we can look up any of these values. Well, the one we used was 1F. Okay, so let's go down to 1F and you can see here that it's 31. And remember we did 127 to 7F. So there it is there. All right, so that is pretty basic. And I think once you know where to find these things and once you know how it works, I don't think that should be a problem with this stuff. All right, guys, so back here, you'll notice down the bottom of my notes, I had MIDI control change messages written here. And you'll see above, I've put a little graphic table. And that graphic table is just representing how our control chain message is set up particularly in the Roland JD-XI. But what is a MIDI CC? It's a continue controller or control chain message. There's 127 spots with some commonly used. Now the JD-XI does implement most of these common C control change bytes. However, the SYSEX ones are the ones that we're going to be looking at in this video. But just to sort of give us a little overview of how SYSEX, hexadecimal, and MIDI kind of works, control change is a good start. Now, this table above shows table 2, which is the status byte, is the first number. This here, B2, is the status byte. In the link on the description below, there's a link to MIDI.org specifications table 2. Click on it and have a look. There's a whole stack of cool stuff in there that you'll recognize. And that's where these bits of information come from. Now, in the second byte, this 01 number here, is the actual control change message. And I'm going to show you in a sec how we look that up. And the third byte is the value in this case. So these two here, these two bytes come from table 13. And once again, that's a list of registered parameter numbers or RPNs. And there's a list in the description for table 3 below from the MIDI.org. Now, how do we set up a custom MIDI CC and how do we demo it? All right, so let's do this over here. And what I said is I was going to show you what these MIDI CC messages look like. All right, so let's have a look here at this program change. I want to set up in my little mapping that this first knob, which is the knob here you can see on the actual controller. All right, so we're going to set up a control change. We're going to use this volume one here. I've just randomly picked one out of the manual. This one's volume. I mean, pretty basic. So we'll call it volume. We need to do a channel message. We need to change that to a control change. The control number, MIDI channel, because we're working on the analog part, it's MIDI channel 3. Control number, as it says over here, is control number 7. So we put 7 in, and the value is, it says it here, 0 to 127. So we'll leave that as 0 to 127, and we'll transmit that. Yes, we're going to overwrite it, and it's receiving. Should be finished in a sec. Okay. Beautiful. That works. Okay, so let's go back to our Mac screen. I want to have a look at this part here, the MIDI monitor. And I want to show you this bit here. As we're turning this knob, you'll see B207, and then the second column here, or third column, sorry, it's a whole bunch of numbers from 00 all the way to 7F. And we know that 7F is 127, and we know that 00 is 0. Right, so all I was doing, by the way, was just all the way to the right, and you can see the little white indicator there is pointing all the way to the right. And if we go back to this screen, you'll see 7F, go back to here, all the way to the left. The indicator's right to the left there, and the screen says 00. Back to our manual, it says control number 7, okay, and BN, in this case, the N is the MIDI channel number, and it said 2, didn't it? Yeah, so it said 2, right? And 2 is MIDI channel 3 because 0 is MIDI channel 1 in hexadecimal, okay? So 2 is actually the third one. Don't let this confuse you, but it does it automatically. So as you could see, when you allocated the MIDI channel in the controller here, it asks you the actual MIDI channel here. So don't get these confused. This is the real MIDI channel, the one that you actually need to know, and the calculation is done automatically over here. The 07 is that control change program number, and the column is the value. So that's all pretty straightforward, I think. And I think now you guys are ready to have a look at a SYSEX message. So let's just, before we do that, let's just go back to our little table here. It said, on the table above, it said B2, and the example was 01, and that was just a random value of 1F, which is what I've written here. Okay, our example was B207, and whatever value it was. Control change 01 on the JD-XI is modulation, 1. Control change number 1. So that example would be a control change for modulation. Easy peasy. Okay guys, so now we're ready to do SYSEX. What you can see I've written out here is a typical JD-XI SYSEX message. And if we look at the manual on page 6, page 6 talks about specifically the system exclusive messages for the JD-XI. Okay, so now you know where to find it. What I'm going to do is I'm going to show you on here how one of these messages is made up. Now, I might actually just jump to a nice little graphic I've done instead of showing you my horrible handwriting. Okay, so let's have a look at the SYSEX message. You can see in that gray row where it's got the F041. I'll just show you here, F04110. I can go back to here so you can see what I'm looking at. All right, and it goes all the way down to the right where it says F7, okay? Now, in this little table, you'll see that I've written notes. Above it shows you the area. So this part here is the header. You can see in the table it shows header. The next part where 1942002D is, that's the address part. And the last 2 bytes is the offset address, and we'll talk about that in a minute. Then you've got data, checksum, and EOX, or end of transmission. Okay, so let's have a look at F0. F0 is the first always start with F0 with system exclusive messages or SYSEX. The number 41 is an ID number. In this case, it means Roland. So if we are going to SYSEX a Roland device, we should put 41 there. The next number 10 is the device ID. So you can set your device ID on any synth, and usually this one is the default device ID. The next set of numbers, model ID 1, 2, 3, and 4. There's all zeros except for the fourth byte, which is 0E, which means the JD-XI. So that doesn't change, you just keep that the same. And then the last, number 12 in the header section, is the command ID. All right, now let's go back to our manual and I'll show you what I mean by command ID or DT1. Command ID or data transmission, okay? And it's transmitting messages that are generated and transmitted system real-time messages. And we're going to look specifically at the start address, and then we're going to look at the offset address. So let's go back to the address section on our little graphic here. You'll notice that it says 1942, and don't worry about the 00 and the 2D for the moment. We're going to talk about the 19 and the 42 for the moment. Okay, so how does the 19 and the 42 work? 19 here is the analog synth part. And then you'll see 40, but we've got 42. Why is that? Well, okay, so we need to go to the table, which is called temporary tone, right? So let's go to the temporary tone table, and you'll notice that the analog synth tone is offset of 2. So you add 2 to the 40, and that's how you get 42. Now, let's get to the offset part. Now, this offset part is really where the meat and potatoes is. This is the bit that the actual air of the synth that you want to change, the parameter. Our 002D, why don't we go find what 002D is in this. Notice how below I've written it's the amp envelope attack time, and then I said see page 12, so I've given us a hint. Let's go to page 12. Okay, so there's page 12. 002D, where are you? There you are there. Amp envelope attack time. Beautiful. So, and notice on the right hand side we see 0 to 127. So that's the allowed values that we're allowed to supply. Now with a SYSEX message, we can either supply a static value or a variable value depending on the type of device and how that device works. Now in our case, we've got a MIDI controller, and the MIDI controller has knobs and sliders. And as a slider moves, the value changes. So what this DT means is that it's a command, and it's only specific to this Roland A-500 Pro. But if I go to our MIDI controller and I click on this slider here, and I assign it a system exclusive message, you'll see this data type and DTO here. See this DTO? Now, when we are entering this message in, we're going to enter this exact grey line here, F04110000E1219420002D DT00F7. Okay? We know that this is the amp envelope attack. And this is where we enter this SYSEX message, F041110000000E12. 1942, which is the analog synth part, 002D, which is the amp envelope attack. The next value is DT, that's a command. The checksum is 0, and we always end the SYSEX message with F7. We set our values to 0 to 127, and we're going to transmit that over to the controller, and I want to see if okay, we've got to turn our volume back up. Let's get an attack time. Oh, that's working beautifully. Now, this particular tone that we've selected doesn't have a very long release on it. So, what I want to do first is I want to show you that SYSEX message. As I adjust that slider, we're going to lift the slider all the way down and all the way up. You'll notice that if you look at the column C there, is the only thing that's changing as I move. You watch me move that slider up and down. Okay, 0, 0, all the way to F7. Sorry, 7F, all the way back down to 0, 0. Now, let's look at that whole SYSEX message. F0, 4, 1, 1, 0, 0, 0, 0, 0, 0, 0, 0, E, 12, 19, 42, 0, 0, 2D. There's a bunch of numbers that change. Then there's the checksum of 0, 0, and then there's F7. Let's go back to our chart. That's exactly the same as what's on here. Whereas the data column, DT, is column C here, is the only column that changes. So there's your first SYSEX message, and that's so easy. What we're going to do now is we're going to add decay, sustain, release, because I want to show you that the attack is actually really working. You can't really hear it on this particular patch. All right, so let's quickly do those. Now this is really easy because now that we've got the data for this one, we can just copy it. Okay, this string here, we can just copy this part here, this part here in the blue. Okay. And we're just going to paste it. This is going to be amp, envelope, and the next one's going to be decay, right? SYSEX, paste. Now, the next value, amp, envelope, decay, is 2E. So that 2D there changes to 2E, and everything else stays the same. So we've done attack, 2D, decay, 2E, sustain, 2F, release, 3, 0. Beautiful. Transmit. Now, notice how on the control map LCD, you'll see it say amp envelope attack. Okay? Now you'll see it say decay. Now you'll see it say sustain. And this one you'll see release. So let's listen to the tone now with no attack and quite a long release. Did it work? Maybe not, because maybe it's got a filter release on it. Filter is the one above it. Filter attack is 25, 26, 27, 28, 29. Okay. Filter and attack. Make sure we're on the right control map, and it should say filter attack, filter decay, filter sustain, filter release. Here we go. Now let's try our short release. Knew it was the filter. Now let's try attack. Righto. Why don't we do cutoff and resonance up there on those knobs? This one we're going to do SYSEX this time. Cutoff. Filter cutoff is just very similar to those last ones, but it's 2-1. And we're going to do resonance. Resonance is 2, 3. Done. Transmit. Back to the synth, or the controller I should say. Just about finished receiving. Now we've got filter. resonance. Works beautifully. And while we're doing that, let's just have a quick look at our MIDI monitor over here. Columns 0 all the way. You can see the SYSEX. Now I'm going to adjust the cutoff. You can see column B says 2-1. The resonance, column B is now 2-3. Now let's do the attack slider. It's 2D. Decay, sustain. So you can see all those SYSEX messages changing as I fiddle around with our sliders and our knobs. Okay, Aftertouch. On this MIDI controller, we have Aftertouch. And I want to show you, because the JD-XI doesn't have Aftertouch. So we can assign something to this. What would you like to assign? Let's assign filter. Let's try filter cutoff. 0021. This will probably be crazy, but it'll prove that it works. And here. That's definitely full. That's cool. Okay, I'm going to finish mapping a whole bunch of stuff onto this. I'll be back in a sec. Alright, so I finished doing all the mapping and I'm going to put all of that mapping already. I'm going to put it as a link in the description. It'll be a MIDI file that you can download. If you've got an A-500, 500 or 800 Pro, it'll just go straight in. If you don't, then yeah. Last part of the video is, what if you don't have a MIDI controller that does SYSEX? So in other words, you don't have the ability to do SYSEX. What happens then? Well, what options do you have? Could you use a computer or an iPad or an Android? The answer is yes. And there's plenty of software out there. And what I'm going to do is I'm going to list a couple of examples of computer / iPad / Android software. I'm going to list it in the description below. I'm also going to show you a couple of hardware devices that can be used as well. One of them I'm going to show you right now, the Roland A-01 Boutique. This is actually able to send SYSEX, and also it's able to do it over Bluetooth. So if you've got one of those, or if you're thinking about getting one, you will be happy to know that it does SYSEX, and it does it without even having to use a computer. You can actually just enter the SYSEX string straight in there. There's other hardware devices. There's hardware in between. So you've got a controller and then you've got another device that goes, the MIDI cable goes into that, and then the MIDI cable out of that device into your synth. And they can do SYSEX programming as well. So they can receive, you can program these faders on a MIDI CC, because your MIDI controller might not do SYSEX, so you can program these to do MIDI CC, and then you can have that MIDI listening device translate that CC message to SYSEX. And they're called things like MIDI PAL or MIDI Bro. There's even the MIDI Solutions MIDI Event Processor, or the Retro Kits cable, the RK004. I've put links in the description for those as well. Anyway, that is it. Hopefully you guys aren't thinking, wow, this stuff in this manual, it looks like gobbledygook to me. It looks crazy. Hopefully now you understand what it means. It's all pretty simple. It's just how to set up your message. It's that easy. Write some notes. I wrote some notes. Even before I did this video, I wrote these notes here on how I was going to set up the amp and the filter envelopes. So that's pretty easy. Learn about SYSEX. It's really not that hard, and at the end of the day you can end up with a nice MIDI controller with custom mappings, and it's controlling that synthesizer that you've always wanted to control. And there's plenty of them out there. JD-XI is not the only one. There's plenty of synths out there that have got hardly any controls on them. In the 90s it was a fad to put hardly any controls on synths. Hopefully this video will help those people, even though it's not specific to that. If you like the video, please give it a thumbs up. Please tell me in the comments what you liked about it. Stay tuned for some cool stuff in the new year. I want to wish everybody who is a subscriber to my channel a happy Christmas and a happy new year as well. And I want to thank everyone for being subscribers to my channel and for supporting me. And I look forward to seeing you guys in 2018. So it's awesome that you guys are there. I really appreciate your support, and we'll see you guys soon.